as we consider angle measurements, we really have two options. Degree measure is often the life application choice. Degree measure starts at 0 degrees, then 90, then 180, and 270, and all the way around to 360 degrees. So I'm going to do a really poor job of drawing this. But if we think of a degree, 1 degree, we would think of 1/360th of a circle, right? You put 360 of those together and you finally make it all the way around. That's a really small thing, isn't it? Like, if you think of a foot, you're like, well, okay, there we go. Okay, you look at your shoe, you're like, okay, there's a foot. But 1 degree, it's kind of hard to slice it off, isn't it? You ever thought about that? Why do you think they chose 360 of them? Why not like four? Okay, four would be better. I can count them right there. 1, 2, 3, 4. Maybe eight. 1, 2, 3, 4, 5, 6, 7, 8. Like that better. Why do you think they chose 360? Yes, 360 is a very divisible number. So 360 is divisible by 10, by 6, by 9, by 90. All sorts of numbers go evenly into 360. I think it might also have to do with the fact that it takes 365 days for the Earth to make a full revolution around the sun. So 365 is not so divisible, but 360 is somewhat close. I don't know if that's a little bit of the frame of reference, but maybe. A radian is different. And this is what you're going to have to do now. Kind of like how you compare miles and kilometers and kilograms and pounds. You're going to have to come up with a frame of reference to think about degrees and radians. Radian is not the life application. It is the mathematical graphical representation of angle measurement. So probably what you want to know is how many radians would fit in a whole circle. It's probably something you want to know, right? Maybe it's 2, maybe it's 4, maybe it's 8. It's not a real nice number, but I'll show you. The definition of a radian, 1 radian, is this. When I take a radius, call R, this is kind of cool. You gotta get kind of geeky about this. I'm gonna pick that radius off of there, and I'm gonna lay it on the side of the circle. Okay? For example, is that more than 1 radius or less than 1 radius? Would you agree? Okay, so I need one person to volunteer and tell me when I've drawn approximately 1 radius on the side. Who wants to volunteer? Okay, Faye, you tell me when you think I've done it. If you do it wrong, we'll just do it again. Okay? I think that's pretty good. What do you guys think? I'm going to take just a little bit off here. I'm going to call it that. I would say that distance, and then that's also R as well, isn't it? When R and R are the same as the arc length, that angle measurement right there is what we call 1 radian. Yes, when that happens, it's 1 radian. I'll show you. I'll show you. Okay. Now This right here is 1 degree. We use the degree symbol to mark a degree. You know what I use to mark a radian? Nothing. I just put 1. So if you don't see a degree symbol, it's a radian. What's bigger, 1 radian or 1 degree? That's correct. 1 radian is bigger. About how many radians, or about how many of these degree things do you think maybe fit into the radian? 45 is a good guess. A little bit more than 45. A little bit more than 50. Not quite 60. It's right around 57. You're kind of wondering, why is that? I'll show you. The aha moment's going to come here. You guys are going to be like, wow, this is really cool. Watch. Watch. I'm going to draw another one. That's my second. Okay. I'm going to draw another one. That's my third. Draw another one. Fourth. This is the aha moment. This is where you really got to think about it. Okay? About how many radians fit an entire circle? About 6. Is it more than 6 or less than 6? Less than 6. Look at just half of a circle. About how many fit in half of a circle? 3. More than 3 or less than 3? A little bit more. What's a number that's just a little bit more than 3? 3.14. See it? So it's tough to think about, right? But it actually, there's a lot of connections that way. It's really good for us. It ends up being pi. Okay, so it's 2.2 pounds in 1 kilogram. Okay, it's about 1.6 kilometers in a mile. Okay, and it's 3.14 radians in 180 degrees, and that is how we make our conversion. If you have theta and it's in degrees, theta is going to be our symbol that we use for angle measurement. It is a Greek letter. If I were to spell it in English, it would look like this, theta. As I spell it in Greek, it looks like this. Theta. Right? That's the Greek letter for TH. Okay. In order to go from degrees to radians, we take our angle, whatever degrees is it, and we multiply it by pi, and we divide by 180 degrees. If we have theta and it's in radians, and we want to convert it to degrees, we multiply it by 180 and we divide it by pi. See that? That's our conversion. So our goal today, our learning objective today, is to convert back and forth. Let's try a couple really easy examples, and then we'll try a few little bit harder examples, okay? So today we're simply going to focus on conversion, and then on Monday we're going to focus on filling out what we call the unit circle, or otherwise known as the circle of life. Okay. Some people when I got here they call it the circle of death, and I thought that was rather dark, so it's called circles. Okay. So Watch how this works, okay? Rewrite each angle in radian measure as a multiple of pi. So right now it's in degrees. In order to go from degrees to radians, I need to take theta and I multiply it by pi divided by 180. So I take 0 times pi divided by 180. What do you get? 0. So 0 degrees is the same as 0 radians. 30 degrees. 30 times pi divided by 180. Or 30 pi over 180. This is what we have to reduce, okay? This is what we have to simplify. Does 30 go into 180? How many times? 6 times. So this will simply just be pi over 6. So 30 degrees is the same as pi over 6 radians. If you have your calculator, you can take it out as well. You can take pi and divide it by 6. Pi over 6 is approximately 0.52. So about a half of a radian, okay? Not a full radian, about a half, okay? Let's do 45 degrees. I would take 45 and multiply it by pi and divide by 180. Or 45 pi over 180 degrees. Does 45 go into 180? Let me show you what you can do. First of all, 45 is divisible by 9, right? So you do 45 divided by 9, you get 5. 180 is divisible by 9, you get 20. And 5 goes into 24 times, so we have pi over 4. Some of your calculators do have fraction options, and you can just simply leave off the pi and say 45 divided by 180. And my fraction button is in math, and I can hit convert to fraction, and I get pi over 4. I'd like you to do that to check your answer, but I'd like you to actually try to find it out without hitting the fraction button. Next one, 60 times pi divided by 180. Does 60 go into 180? How many times? 3. So we get pi over 3. $90 pi divided by 180. Does 90 go into 180? How many times? Twice. So I get pi over 2. Does 105 go evenly into 180? No. Let's see. What might 180 and 105 be divisible by? 5. Let's try it. So 105 divided by 5. We get 21. And 180 divided by 5 is 36. Are 21 and 36 both divisible by the same number? 3. So that'll be 7 pi over 12. Let's try 240. 240 pi divided by 180. If I want to simplify that, what can I cross off? The zeros. Are 24 and 18 both divisible by the same numbers? Pi is 6. right? So 24 divided by 6 is 4, and 18 divided by 6 is 3. 4 pi over 3. 360 times pi divided by 180. What can I cross off? Zeros. Are 36 and 18 both divisible by the same number? They're actually both divisible by 18, aren't they? 18 goes in 36 how many times? 5. Okay, I'm going to give you a worksheet. We're going to do about 3, 4 problems together. Let's look at problem number 1. Problem 1 says, oh, sorry. I'll give you one, Jasmine. Yep. Again, just the odds. If you look at number 1 says convert each degree into radian measures. And you can have negatives. We'll talk about that later. But negative 290. And we multiply by pi. And we divide by 180. So I'll do this one by hand. What can we cross off? Zeros. Are 29 and 18 divisible by the same numbers? No. So we got negative 29 pi over 18. That's all it is. Look at 3. 970 pi divided by 18. Or divide by 180. What can I cancel off? Zeros. Are 97 and 18 divisible by the same number? It's hard to tell, isn't it? And so maybe you leave it like that, and then you can go to your calculator and check 97 over 18, and you can convert it to a fraction, and check to make sure you're correct. In fact, it doesn't simplify. Okay. Let's move to number 21 and 23. 21 says convert each radian into degrees. In order to convert from radians to degrees, I take whatever theta is and I multiply by 180 divided by pi. So this is theta, and I will multiply by 180 divided by pi. What do you notice happens? What do you end up with in the numerator and the denominator? That's the same. You end up with a pi, right? So these just cancel right off. Exactly. 180 divided by 18 is 10. So you get 10 degrees. The next one, 35 pi over 18. And we will multiply by, again, 180 over pi. What should I cross off right away? And 180 over 18 reduces to 10. So you end up with 35 times 10, which is 350 degrees. So as you look at your worksheet, the odds on the first part are going to have you go from degrees to radians. And then the second part, radians to degrees. And then 41 through 59 odd, you have to determine which one it is and switch it, okay? So you're going to have to use one of the two formulas. So remember your formula. In order to go from radians to degrees, you use this one. In order to go from degrees to radians, you do this one. Those are your two formulas. That's what we're practicing today. Fair enough?